Thank you very much, everybody at InterTrust, to give me this opportunity. I know you guys have a pretty busy day today, probably a pretty big day as well. A lot of people talk about AI, and AI has many connotations, especially now from a commercial perspective. Fortunately for us, Om Malik, the GigaOM fame guy, wrote an article in the New Yorker just this week talking about what is this AI? Really, is it replacing human beings? Is it going to replace human beings? Or what is it good for even? There's naturally all the conversational intelligence, which is in the context of bots. And then separately from that, there are like three tiers of artificial intelligence that Michelle Zhu, who is the IBM Watson lady who left to form Juji, she's the CEO and founder of Juji, she's described sort of these three levels of artificial intelligence. And she says recognition intelligence is like level 1 AI. Being able to recognize the world you are in potentially a narrow enough manner is the first step of AI. And then comes cognition, which is really understanding what is the context of what you have learned. And then comes the decision or the action intelligence. So when we talk about AI in the context of our work, it's really recognition intelligence. And our work is focused entirely on time series data, kind of like what you see in the background over here. And we believe that this is important because the world around us is being shaped by a lot of data that is coming from a variety of time series. But before I go into that, just very briefly, my background is mostly in distributed systems as well as data management. I did my tour of duty at Oracle. I worked in the database group. One of my legacies is that I wrote the standard called IndexedDB, which is now present in every browser on every device imaginable. And that's the database standard for accessing in an efficient and scalable manner data in browsers. But for the last 4 years roughly now, I have stepped out of my work as a professional and much more into an entrepreneurial role. Prior to Falkonry, I was at C3. The name is now C3 IoT, but that's a company that is making available a platform for people to develop energy applications, even IoT applications. And that's where I got started in this world of time series and analytics on this time series. So why does it matter? Even just putting this picture up tells you what I mean by time series. I hope we are all on the same page in terms of what time series means. It's data where there is a timestamp and where you collect over time lots of data. That's time series data. And this data is coming from a variety of places. It's coming from industrial deployments of sensors and automation systems. It's coming from vehicles. It's coming from enterprise systems as well as from IoT, right? And all of these different sources of data are creating a massive amount of data, time series nature, that far exceeds what we are able to do anything meaningful with, right? Can't visualize that much data. We could potentially store some of it, but even that we cannot do all of it. And in the most common scenario, it is just a byproduct of doing something, and so the byproduct is lost. It is sort of tossed out because there's no use for it for holding all of it over the long term. But we believe that that's going to need to change. These exabytes of data that is coming through will need to be made sense of. And that making sense of it is where Falkonry and its recognition intelligence comes into play. Now, this is a very simple pictorial representation of what we mean by making sense. On the left here are sort of parameters that can get produced from a transformer in power distribution systems. And this can be temperature, the load tap changer position, hotspot temperatures, and so on. All of this is of a time series nature. Now, typically, we can put thresholds on them. We can create formulas on them. And through that, try to mark a particular onset as a potential condition of interest. That's what is typically the state of the art. In reality, in the minds of an expert in a certain domain, They are interested in knowing what is the regime in which something is currently operating. Right? Alarms are only a way to know what is the regime that this thing is operating in. In the most simple logical sense, its sort of regime that is indicated by a color here is in effect from time t1 to time t2. Right? So we call these regimes as conditions. And what somebody is really interested in is knowing what condition is a certain system in based on what you can observe about it, which is naturally time series. Right? And if you have these conditions such that they are early, reliable, and actionable reports of conditions, lots of interesting things can be done. You can make things more efficient. You can reduce waste. You can avoid breakdowns. You can guarantee certain kind of performance. These things are constant endeavor in any industrial activity. And this time series data and all the observations that we are making about the world that we care for is a means of improving what we know about our world in the form of conditions. This is sort of the general scheme of things in IoT, but for that matter in industrial internet, as well as in IT operations where computer metrics are getting collected. So we believe there is a generalization across all of them where we need to go from data to conditions. Now, what are alternatives? What are the options to do this? Presuming that you believe that there is a lot of time series data, that is actually good data, that something valuable is in them, and that going from data to conditions makes sense, how do you do it? Right? There are three choices. First one is you do it yourself, right? Which means you gather all the data, you bring together all the tools, you hire a lot of smart people, and you try to figure out what is the meaning of the data in the world that you're operating in. Right? That's one approach. The second approach is you outsource. You say, I have this business, it operates at this level of efficacy. You, my outsourced partner, make that KPI this much better. Right? That's sort of the other alternative. Sorry, I think. Yeah, maybe there is an animation in here. But the third alternative is you have an existing team of people who are your operations experts. To them, you can provide Falkonry, and for them now it's no longer a project. It's a task. They do it on a daily basis, they spend 10 minutes on it, or when Falkonry notifies them of an important condition, and they continue to derive value from that data in the language of conditions. And they do that on their own. You don't need to give them a team of data scientists or a company to which this job is outsourced. And we believe that this option is the really scalable option. This is the option that one way or the other is going to become more prevalent. Although these other options will remain and they will have their own particular benefits in various areas, we believe this is the one common approach that we are going to see in lots of places. So just like there are companies now that focus, for example, Clarify on image recognition, or other companies that do speech recognition, like Nuance used to do that, or some that do video recognition, and some are beginning to do fingerprint recognition or texture recognition. This cognitive recognition intelligence is going to come to time series. We are trying to bring it, and it is likely that we are far ahead of the others, but this field is going to come. It's needed. There is an economic incentive for it. So what do I mean by conditions? Let's take a few examples here. So let's say you have a fleet of trucks, right? There are various interesting things about a truck, right? Who is the driver? What's the direction in which it is going? Right? You can measure a variety of things about it, about its location, about its activity, about the driver itself. A condition in this context would be if you know that there is an impaired driver, or that there is a tire problem or an engine problem. Right? So those are conditions. So practically in every type of a device or in any type of a data source, there are conditions. And these conditions are inherent in the domain for which you put the instrumentation to collect data from it. The one interesting thing about the time series world that we are operating in is that these time series come out of systems that are relatively reliable, or at least have been engineered. These are not toys, they are actually systems, right? Let's take an example, a human being. It's actually a system. It's evolved, biologically, genetically, but it's a system. It reliably works. Human being expected to live 85 years in Japan, 75 years in the US, right? It's actually a reliable system. And so when you measure various aspects about it, that information, if it is on the basis of some science, is actually relevant information to make conclusions about its condition. Same thing with a truck, for example. These are industrially plied automotives to perform a certain task. And so if you measure some of this information about it, it actually holds signs of conditions that matter. Right? And so that's why we believe that the time series data, just as importantly as the design of the system that you might have done in, let's say, in a CAD design environment, is equally important for understanding what's happening when the system is working. And that you can derive from it understanding of the condition of these systems. Now, these are some of the challenges that people encounter when they go from data to conditions. These are natural challenges that have to be dealt with. You cannot avoid them, right? And depending on the approach taken, some of these are exacerbated and other ones are ameliorated, right? It depends on which path you took. It's outsourced, DIY, or Falkonry. And what we found is that the Falkonry approach presents to that operations expert a path that allows them to converse with a computer. And that conversation becomes the basis of productivity and efficacy in making sense out of the time series data. So let me tell you how. And I'm actually going to go into the demo, but feel free to stop me at any point if you have questions. This is the standard sort of IoT architecture. Right? You have sensors or other sources of data. There is a high rate of data traveling into a system. You ingest it, you hold on to it, you create some operations management solution that is able to dip into this data and either provide information to humans and technicians, or you automate some processes. This is very standard. I don't think there is anything new in this. So what we do is we tap into this time series data such that we will add to the raw time series findings of conditions that Falkonry has made, right? And so at every moment in time that you're collecting data, you also know what is the condition. Now, if you know what is the condition, and if it is co-located with all of your other time series data, then whatever you can do in this solution, you can do with the time series data, the condition results as well. You can fire off automation jobs. You can present alerts and notifications to those technicians. You can create dashboards. You can create reports to see what has been going on in your world, right? So it's no different, except that that is a higher level of know-how, right? Now that higher level of know-how can be at many levels. So when we were looking at fleets, for example, it's one thing to know that there is an engine problem in this one, or that there is an impaired driver in that one. It's another thing to know that across your fleet, there seems to be an unusually high level of tire problem going on in this last 1 week. Right? And you want to know it early enough because it is likely triggered by the new make of tires that you are putting on your trucks. Right? These are fleet level assessments. They are not about an individual truck. It's about your trucks at large. So that's what I mean by levels of knowledge. You have one signal and one measurement at one point in time. That's like the atom. Everything else gets built on top. And so these assessments are actually being made from other raw data or potentially even other assessments. So just before I dive in, this is what actually happens inside that orange box we are looking at here. So if you dig inside of this, you have signal data that is flowing in. There are models, we call these cognitive models, of interpreting that signal data, getting applied to it. And then through that model, Falkonry is producing condition assessments. Right? These condition assessments are point in time. So at every point in time, we assess what's the condition now, what's the condition now. So we continuously produce assessments just as long as data from these signals keep coming. Any questions so far? I know it's a little dry. We can dig into an example so that we can illustrate. Are people online going to be able to see all this?
I don't think so.
Okay. Right.
It's just audio.
Sounds good. All right. So what I'm showing you here is data from some wind power turbines. They're called plants in the domain. So that's why we see here plant number. So we have two different plants from which SCADA data was produced. And this SCADA data was available to the plant operator to understand what's going on with this plant. And as you can see here, this is over a period of a year. Right? This extent is a year. And there's a lot of behavior that is going on. It's going on in terms of what's happening inside, like motors and control cabinets and heat sinks. Also in terms of what's happening outside, such as wind. Right? All of these things are affecting the behavior of various parts of the wind plant, as well as the power that it is producing. Right? These are only some of the signals. There are probably more that were available. These are some of the others. Now, through this information, not knowing anything else about what is the meaning of a nacelle position, or how does RPM relate to wind speed, right? Let's say that one does not know all of these answers. Then how do you make sense out of all this data? Right? Because it's an equation of sorts where you have to put some stochastic behavior to really understand how everything is related. It's too complicated. Most people who operate equipments are not the ones who can design them. And that's, I mean, by necessity, operators need to be able to do these things day in and day out without being experts in the design of these things. Which means that if they have to interpret what's going on the basis of these pictures, there is information in these pictures themselves. There is insight about those conditions that's actually present right here in front of us. It's just difficult for us to tell what it is. And that's where recognition intelligence comes into play. So what Falkonry does is it will translate this picture into a picture of conditions. And it does that automatically. There's no programming required in Falkonry. So this interface that I'm showing you is the interface by which you can translate raw data into conditions. Right? And so at first I'm just showing you the raw data, but through click of one button, Falkonry will go in and find out the conditions that are present in this data. And so what we are seeing now are these 5 conditions that occurred during this entire period of time. Right? Again, Falkonry does not know what conditions that you are looking for. It doesn't know the meaning of each of these individual signals. All it knows are that there are numbers and they relate to a certain signal and vary over time. That's all it knows. So Falkonry is then breaking down this entire period of time into 5 different zones. Now why 5? Well, it seems that there are 5 in this data. If there were 7, Falkonry would have said 7. We don't know how many there are actually. For that matter, nobody really knows how many there are. It's just the best guess possible. Falkonry from the data perspective found that there were 5. Now you can see that there are certain conditions arising on the left here that don't seem to be occurring as often on the right. So something must have changed about the behavior of this system over that period of time. But that itself is not very interesting, right? Yes, it helps me understand that there are 5 different behaviors. And potentially, if I said, let's focus just on this U1, then I could say, okay, can I ask somebody to go out and say, what was going on that particular day, on July 17th? Maybe somebody has a record somewhere that they can use to corroborate what Falkonry has found. And that's effectively what we ask people to do, is we say, do you have any records of what was going on that was maintained by a human or an expert? And if you do, then let's use that information. So here is an example of where we use that information. We said that particular period of time that Falkonry had found, you see that big dip, that was a condition called C240. Somebody had a record of it. And oftentimes in these wind power plants, in addition to the SCADA data, there is also alarms. So the C240 was an alarm that was produced, and hence there was a record of it. So somebody came in and said, yes, that particular blue mark is C240. And it's actually easy to do. You can come into Falkonry, click on that, and say whatever it is that you want to call it, let's say C340. And you apply it, now Falconry knows that that particular blue period of time is C340. Now the name is up to you, naturally. I'm going to cancel this out. So that was that C240. And the user may have more than one example of C240. So they might this one, but then they might also mark another couple of these. Right? C240 is one condition. Somebody may also know that there was what can be considered as normal behavior. Don't worry, everything's fine. Right? Maybe they had some point of time a normal behavior, and they can mark off like these episodes of time. Right? Once they mark this information, we call these as facts. These are facts. Once you mark these facts into the repository, now Falconry knows a little bit more. Not only does it have the raw data, but it will also have some facts. Falconry can now use the additional information to better understand the world that was being observed. So at this time, I will bring in the assessment Falconry produced using the facts that were provided. So now you see that the color is changing. Right? Now we actually have a fair amount of normal color here. Right? So we did not tell Falconry that this is normal, but Falconry was able to conclude that this period of time was also normal. Now there's a little bit of leak going on. The normal color is sort of overwhelming. So I'm going to just highlight the other ones. So now we can see everything that is not marked is normal. And all we are left with is the behavior that Falconry could not conclude was normal. Right? You can repeat what we did the previous step. We can add some more examples. For example, I might want to mark a particular period of time as, I think somewhere over here, let's say. This period of time, something is going on here. And maybe I have knowledge that there was a pitch issue discovered at that time. Right? Now you notice that this particular condition that Falconry is reporting, the unlabeled 4 condition. Yeah, sorry. So let me go over to the 3rd revision now. So I can see, for example, in the display that will come up here, that there is a distribution, almost a power law distribution of conditions. And some conditions were happening very rarely. You can see some of these are a very small amount. So I could, give me a second, I had some prior settings, so that's what it was showing me. Okay. So this is my, all the blue is the normal. And there was some other behavior that I found was extremely rare. And I'm going to say, okay, let me dig into just the rare behaviors, because those rare behaviors are likely the problem conditions. So you see here there are a bunch of very small amounts, the epsilons that are marked. And one of those epsilons is this U4. So I'm going to go ahead and mark one of the U4 occurrences, which is over here. I'm going to mark it as a pitch issue. So this is my pitch issue. Okay. So Falconry made a suggestion. There's something unusual going on at that time. What do you want to call it? I gave it a name pitch issue after looking at my records or perhaps even inspecting this data. An expert typically can do that much. Once that expert did it, we can again ask Falconry, can you now make sense out of your word? And Falconry will go back in and say, okay, let me combine the original data you had plus this example you gave me, and Falconry will now find, as you can see, 1, 2, 3, and 4 other pitch issues. Right? So this is sort of a conversation through which, purely on the basis of the raw data and some example facts you're able to provide, Falconry is able to create a cognitive model for fairly complicated data. And there is no program. Right? So this is what we mean by AI. It's only truly AI if a domain or subject matter expert can work with the computer. Otherwise, it's not AI. You think about Siri, for example. You have a phone, it may be making mistakes on the accent and is not grabbing the word that you are speaking. You have the option of telling Siri what you mean. And then Siri has to remember what you had taught it so that it correctly applies that example to interpret what you are seeing. That is AI because you are not programming it in the sense of coding it or tuning it. And that is what enables a device like that phone to be used for speech recognition en masse. Then it's no longer being used only by a doctor under constrained conditions with special software and a lot of training. Right? Then it becomes truly mass market AI. And that's what Falkonry is trying to create that kind of mass market AI. Now, in order to make that happen, there's a lot of work that happens inside Falkonry. So I say that there is no programming, but I mean, we still have to do programming. That software still has got to be shipped. It can be run anywhere, meaning not on your phone yet, one day maybe, but it can be shipped into a server, run inside a plant, and it can start learning all kinds of things. We don't need to be there. We don't need to make any changes to the software. Right? That's what we mean by no programming. And this orange arrow that you're seeing is what is inside Falkonry. Right? So it's doing a whole bunch of things, starting from the raw time series data. It's actually translating that data until you get to conditions. And it is doing that in a way such that every step of the way, it utilizes what information was presented to it to build algorithms that are tuned for that type of data. So there is adaptation that is being performed of these algorithms based on information theoretic measures that we can derive from the data, so that the right techniques can be applied to make sense out of the data. One of the critical things that we do is extracting temporal features from this data. Naturally, this is time series. Time is a very important characteristic of this data. We have to be able to interpret time. One of the prior generation of technologies where time was being interpreted was complex event processing. Right? And some people have used probably, I think it used to be called windowing in SQL, where you could construct windows over SQL data. And you could apply a query over a window. And that window used to think about usually not elapsed time, but the time as recorded in the data. Right? And so these are some prior generation techniques where you could interpret time in the data. But when we talk about interpreting time, we're actually interpreting the shape of data as it is created over time. We're also interpreting the frequency characteristics of data because there is oftentimes a lot of frequency characteristics. So it's both these aspects, frequency as well as the shape, that Falkonry relies on to do its work. Right? And because these things are happening inside Falkonry, over time we add more. We take into account other characteristics that constitute a temporal feature that may not be adequately picked up by one or the other technique. And so this temporal feature becomes Falkonry's mathematical understanding of the data that it has been presented. And that's where there is a handoff beginning to happen to the human world. Right? So that human world needs to understand in terms of names, in terms of groups or symbols. And that's why we go from features to clusters, so that even if you had no understanding of what's going on, Falkonry can at least help you start to make sense out of your world. Once you are in the cluster space, now, like for example, we went suddenly from a year's worth of 30 signal data collected every 10 minutes to just 5 symbols. Right? Those were the 5 colors we were looking at. So that's the basis of, that was done on the basis of this clustering work. But then when you started providing me some facts, I was able to incorporate those facts to better organize Falkonry's findings for me. And that organization begins to take place in the language of the user. So depending on how many facts you present, Falkonry will organize it better and better. This process that's happening to the right of this box is called semi-supervised learning. Now, semi-supervised learning is different from how, for example, Google has learned to recognize cats from videos. The reason is very simple. There are probably a few million videos of cats, each of which have either comments or title that says cat. And so you have tons of examples of what is a cat. When you have that, you can do supervised learning. But in the most cases, when we are dealing with time series data, that kind of data is not available. No one entity has all of the data. That can be considered as enough. And that is where having semi-supervised learning actually gives you a chance of cracking this problem. Okay? Last thing is that you're never really done. These cognitive models are never finished. You have to keep improving them. That means maybe once a quarter, maybe once a year, you've got to be able to make these models become better. And how often really depends on the business situation, goals, etc. And even computational cost, because there's cost of revising these models. So in order to improve models, it should be no more complex than creating a model. Effectively, in fact, what Falkonry is doing is the cost of creating the model goes down to zero. Because there's no programming involved, right? Just imagine. If this can be done as a side activity, as one of the tasks that you perform every Thursday morning, you don't need to give a very large amount of budget to be able to keep these models up to date. And that is one of the fundamental breakthroughs of AI, that if you can make AI available in the hands of whoever relies on it to do their job, then they can keep it up with support from the vendor of that AI software. And so Falkonry technology will be appropriate for you to keep revising these models from time to time. All of this is taking various people that we work with anywhere between 6 to 18 months to put in place for the first use case. Right? In a way that these end users can start to interact and evaluate what they are getting back from the software. So setting up this is non-trivial. Even if I gave you a list of all the algorithms and all the techniques and the math behind it and the libraries you can use, it'll still take time to figure out how do you put it all together. So none of this by itself is basic research, is a fundamental breakthrough. None of this is a fundamental breakthrough. The fundamental breakthrough is in being able to translate that vision that says everybody whose job is affected by that time series data ought to be able to make sense out of that time series data. Right? How do you realize it? How do you make that a reality so that people are able to do it? That's really the hard part. It's all about the execution. The idea is I'm giving them away. Right? So that's what Falkonry does. And we've been applying this in a number of domains. We've applied it to IT operations. So we can look at logs that are being produced from computer metrics, where people are using it to find out if there are problems that are likely to arise in database systems, in web servers for e-commerce, as well as in these, I guess, are you guys familiar with historians? Historians are the technology that are used to store operational data. So in the operation of the historians themselves, we have customers that are looking to understand the time series patterns of the system's behavior to know what problems are happening. So that's IT operations. In the industrial world, we are working with wind power generation, with chemical manufacturing, with paper manufacturing, and with automotive manufacturing. We're also beginning to use this in human activity and wellness. So some people are using it to find out for gerontological care, old people care basically. What is their health level? Are they tired? Are they sick? Are they disabled temporarily? Right? Those kinds of things from the sensors. I mean, if I tell you a couple of the most interesting activities that are going on, you'll be amazed how far this kind of technology can go. We have a customer that's using Falkonry to predict an earthquake 2 weeks before it happens. Just imagine what that does. Right now, our earthquake warning systems can give us probably 5 to 10 seconds. That's what California government and NOAA is trying to put in place. 5-second early warning, 10-second early warning. We're talking about long range, meaning 2 weeks. Another project is looking to predict a brain seizure up to a few hours in advance. Right? So that is what is present in time series data. And these people who are trying to do it are not themselves data scientists. They are experts in their domain. They understand medicine, they understand geophysics. They are numerically savvy, let's just say that. It's not like they are numerically illiterate. But the level of sophistication to find all the combinations of techniques and parameter values and what can possibly go wrong if you combine certain things, they don't have any of that. So the only way to enfranchise a larger number of people to be able to make an impact on their world that is predominantly instrumented in all sorts of ways, cognitive intelligence, and before that, recognition intelligence is a must. So I'd like to close, and I'm around so I can answer questions. So the point is, look, AI companies are not going to be able to provide domain experience. And companies that have domain experience will have a challenge building this kind of technology that can help them economically solve problems in their domain. Both need each other. And we believe that the right handoff from one to the other is through examples and data. Because that's the language universally that everybody can understand. And that's the interface that Falkonry is trying to polish. We believe that that interface, the more effort we can put into it, the better it becomes for everybody. And that's why that interface should avoid the need for programming or data science tuning. You can definitely do programming in front of it, meaning you say, well, in our world, we have pressure measured at stage 48 and stage 24, and the ratio of those two pressures is critical to conditions discovered in that equipment. Then do one thing. Calculate that ratio. Every time you get a measurement of P48 and P24, compute EPR, send it in as another string, and then it'll get included in the rest of the work. So that's one type of domain work that you can do. Another type of domain work you can do is build regression models or build stochastic simulations on top of this fundamental sort of recognition system. Because those are also going to vary from one domain to another. But leave this recognition piece to be largely mathematics combined with intention. That's what we mean here. The approach from our beginning has been, let's not bring this into our control. Let's put technology in the control of the person who knows what they can use it for. And then lastly, we understand that there is a lot of data, cannot move around everywhere. So bring this technology to wherever the economics of, or the physics of moving data around can work out. So with that, thank you very much for the opportunity. I've really enjoyed all the questions. I hope you didn't feel like I deflected any of them. We try our best as a startup to be very transparent about who we are, what we do, and I hope you like it.